Okay, so here's the game plan. They should sit down. And what I'll first ask them to do is just do the 30-second intro of sort of where they currently are and what industry and that. But I must say that in setting up this panel, first of all, what I wanted to accomplish most was to get a forum which, while engaging all of them, is also going to engage all of you. In that, in selecting half dozen, as you can see, I was at capacity. I was beyond capacity in terms of how many people we could put in front of you. Of course, there are lots of you who are out there I could have equally asked instead. And I wanted to draw on the wealth of experience that our alumni have in a range of industries and let them think back about, I know we've been in business for 50 years, but maybe just even think about the last 10 or 20 years. And think about the evolution of how the tools and the science underlying what they think about and can bring to that industry have evolved, but then also spend some time speculating about where things are going for the next, let's say, 10 years. Okay, 20 if you want to be really crystal ball gazing. So what I'd like to do, so we'll just have them run down each of them, and then I'll turn to each of them in turn to talk for maybe 10 minutes or so and give something a bit depth. So just why don't you all go down and introduce yourselves.
Rehat Güncü from AQR Capital Management. I am a PhD alum from '96. I worked on optimization while I was at Cornell. And I was an academic for about 10 years after that, and in 2005 I switched to the finance industry. I worked at Goldman Sachs in their asset management team until last year, and since then I've been working at AQR Capital Management, working on portfolio construction strategies for quantitative management portfolios.
I'm Teresa Wise, and actually Reha and I overlapped in our time here. I have a PhD through the Center for Applied Math, but did most of my work in operations research and wrapped that up in 1994. And it was actually between my first and second years here, I was homesick for Minnesota and went back to do a summer internship at what was then Northwest Airlines. And I went to work on a revenue management problem, but by the time I got there, that project was dead, and so I found myself working on crew scheduling optimization, which evolved into part of my dissertation. So as of today, I've been there in the airline industry for about 25 years, the last 15 of which I've been the CIO of Northwest and now Delta Airlines, and actually just retired as of the 1st of April.
So I'm Jeff Goldman, undergrad in economics and master's in OR from here at Cornell. I've been with Procter & Gamble the last 18 years, all in the analytics space. Spending the first third of my career in our internal operations research group doing supply chain modeling, and then more recently on the commercial side of our business, starting up and leading analytic organizations in China and Europe, and then about a year ago taking over our enterprise data science group with the mandate to really map out what the future is of transforming P&G's business with analytics.
Good afternoon, I'm Jamie Huntleyan, class of 82 and 85. BS and an MEng in OR, and MBA 86, and for about 25 years have been pretty much focused in the life sciences space in supply chain, and have run the life sciences supply chain practice at Accenture for a number of years, and presently at EY, with a brief stint at Aspen Technology, getting my hands dirty in the software world.
I'm Radhika Kulkarni. I got my PhD in operations research in 1981 from Cornell. I worked as a visiting assistant professor at UNC Chapel Hill for a couple of years, and then took on a role as a developer in the operations research group at SAS Institute, and I've been there ever since for 33 years. And now I head up the advanced analytics R&D at SAS.
Hi, I'm Chris Jones. I'm an undergrad from 1980 and a PhD from 85. I was a professor for 13 years, but I've been in industry now for longer than that. I also worked at AspenTech for about 5 years. I worked for Amazon for 6 years. And right now I have 2 full-time jobs with 2 different companies. One of which is called Marchex, which does telephone call analytics. The second is a company called Atlantic Decision Sciences, and we're building planning and scheduling tools for the next generation. That's a brief intro.
Great. So we can go in order. We can just whoever wants to jump in first. We just would like to go for it. Jamie.
I'll jump in, sure. Well, first of all, Dave, I'm going to go a little bit off script here because I couldn't miss the opportunity to have a special thanks to Messrs. Maxwell, Jackson, Muckstad, Trotter, Shrubin, the list goes on. But I'm here today because of you guys, and what you get is because of you guys. So if you don't like it, it's because of you guys. So anyway, I needed to take that special moment, David, off script here. In thinking about today, and I guess I had the benefit of having heard a number of the sessions, and so I was scribbling madly, then scratching out and scribbling madly again, what I would want to touch upon in my sort of 8 or 9 minutes here. And it came down to 2 things, 2 sort of topic areas that I thought would be relevant. One is what we call the digital operations agenda. And the second is to kind of bring that to life with a vignette. So what do we mean by the digital operations agenda? And a lot of it ties together many of the things that we heard this morning, starting with the first speaker. But it really starts with, there's sort of 3 developments that contribute to this agenda. One is the reality of intelligent machines. And it's not just the devices that are around us every day, but it's plant and equipment that is more intelligent, that have more sensors, that are giving more data. It's products that actually have serial numbers on them that move through the supply chain and are being sensed every day around us. And so this is the first development. So that's the first thing. The second is advanced analytics. Analytics has been around for a long, long time. But it's now at our fingertips. Algorithms, visualization. It's pushed to our personal devices and tablets and so forth. And it's very powerful and robust. It has evolved certainly from the science, but now it's accessible. It is literally at our fingertips. That's the second area of the digital agenda. And the third, and perhaps the most important part of it is connecting people with work. So none of the first 2 things matter if you're not actually connecting people with work. So visualization, things that allow people to actually do their jobs more effectively as opposed to wasting time doing things that they're not supposed to be doing. So that's the context, if you like, for the next piece, which is, I'll say, bringing it to life. And we had a nice sort of taste of some of the life sciences world. So Lee talked about the bioscience and biomanufacturing area. Retzef talked about some of the security challenges in supply chain. And really, supply chain and life sciences is all about planning, making, and moving product from point A to point B. It's like in any other industry. With one difference, you have to do all of that with permission. It's called the regulatory nature of things, and it's not just the FDA, it's every agency around the world that has similar types of requirements. And this is what makes it really difficult. We have the Drug Supply Chain Security Act here in the US, which will require the tracking and tracing materials from manufacture to point of dispensing. That's across the supply chain. And inside the 4 walls of manufacturing, we have new guidance coming out, which basically requires manufacturers to report any kind of deviation that happens in the manufacture of their product. So it's a recipe. You get that recipe approved. It's not just the recipe, but it's how the recipe is executed. That's also approved. And now the FDA wants to know any time that process deviates, you have to report that. It's a drudgery. It's hugely manually intensive. And from a management perspective and from a connecting people to their work perspective, it's almost entirely useless. Unless, of course, you like driving your car forward using only the rearview mirror. In that case, it's an effective management tool. In comes analytics. So now being able to bring together data sets that take that information from machines, plant and equipment, other systems, and creating a single data stack with advanced analytics that actually allow not just the reporting convenience, but leadership can actually manage, can use predictive analytics to anticipate where there might be issues. Operators, line workers, are now actually empowered to do something with information that, again, is at their fingertips. And so I began with this idea of the digital operations agenda, and it's really, we like to think it's about, what's the term that it's the term that I like. It's about zero loss in perfect cost. So kind of a catchy thing, and it's something that would probably come out of Cornell ORIE, right? So we begin with that, and we end with that. So all of the convergence of those items really lead us towards that objective of zero loss per perfect cost. So those are my remarks.
Okay, Radhika.
Okay. All right. I'd like to talk about OR and the role it plays in analytics, because I talk about that all the time with lots of customers, universities. I believe OR is indispensable, and that's what we need to remember. And I'll give you some examples of my own career which prove that out. As I said, SAS is a software company, for those of you who have not heard, and it was known as a statistical software company when I joined, and I was the second member of the OR department. And for a long time, we were a small group. There was not, we knew that it was important for customers, but it was not very critical, high on the CEO's radar. What got us to prominence was when we entered the solutions market and said that we need to develop some solutions which take predictive models, statistical inference forecasting, and then find the best prescriptive methods, so solutions in the area of retail and so on. So it was recognized by the CEO that optimization is going to be very critical in these solutions. So note that it was not because I said OR is an important tool that we got the prominence. We got the prominence because OR was treated as an enabler of success for anything else. And now my division of researchers and research and development is over 200 people in advanced degrees, but we have more than 40 people with PhDs in operations research. And all of that is because we think of OR as not just the icing on the cake. It's now become indispensable for everything that gets done. And a couple of recent developments and trends that have made it even more critical is in the area of big data and analytics. I like to talk about it not just as big data, I like to talk about it as big analytics, because it's not always big data that leads to the need for distributed computing. You really have lots of small data problems, and quite often it's probably in operations research that you run into those. Even small optimization problems can lead to huge CPU times, and the distributed computing really makes all of that possible. So problems that couldn't be solved before are now able to be solved. And so we find, we started out as OR being an important part for the solutions, where it was almost you did forecasting, you did predictive modeling, and then did an optimization model. But now, as we go further into, even within the predictive models, even within the statistical algorithms that we are building, we end up needing to use a lot of OR techniques. And it's just something that has grown over time. And for all the departments and universities, I think that's an important message. And a few examples, quantile regression. That was taught as a topic that, when you learned linear regression, you heard about quantile regression, but people never really thought of it as a computationally feasible algorithm. But now with distributed computing and using interior point methods, that has become part and parcel of what we do. Support vector machines, that's another place where optimization gets used heavily. More recently, when we're trying to build models in this big data world, where every segment you want to build a different model, a different predictive model, it's not easy to get the best model for each segment by actually manually tuning it. Because anybody who's built a predictive model knows that You can get a neural network decision tree, and the best model is probably built by somebody who's tried lots and lots of models. Now, if you've got thousands of segments and you want to build all of that, you need some automation, you need auto-tuning. So in the area of auto-tuning, we've put a lot of effort into some of the algorithms that, like a local search optimizer, and that's very nicely parallelizable, distributable actually. Not just parallelized on one computer, but across a node of distribution of computers. The decomposition algorithms, those have also become extremely valuable where you can distribute the computation. So these are all some of the areas where the fact that we've got big compute available to us has made us even more important to all the analytical areas. In the area of statistics, for instance, observational research studies have become very, very important. So matching patients so that you can create inferences from not a clinical trial, but matching post facto. That means that you need to match patients of like characteristics. So again, pattern matching, the bipartite matching, all of that has become so important. So I find that my team, the OR team, is very involved in almost every area of the analytical discipline. And I think that's something that we should be proud of. So I always like to say, when people ask me about OR and analytics, what role does OR play in analytics? I like to say that the analytics area for the operations research folks, it's ours to lose. It's our market. If we don't take it and run with it, and for that, we have to be sure that we're not just wanting to be heroes as OR professionals, but as people that are willing to play with everybody, work with everyone. And I think that's something that I'm very passionate about, and I hope it resonates with everybody. I guess I'm preaching to the choir here. Right?
Chris.
Great. Well, when David asked me to participate in this forum, I was certainly very honored. And I was also, though, I have to say, quite intimidated, not just because of the quality of the audience, but because David said, what's going to happen in 20 years? And predicting the future is pretty hard. If I look back for just a moment, 40 years ago when I arrived, up the road were Kodak and Xerox. We all know where they are right now. And I'll never forget going on a factory tour with Professor Maxwell up the road in Portland to the Smith Corona typewriter factory, and they were the market-leading typewriter company at the time. If you go back 20 years, which was 1996, Amazon had just been founded the year before, but Google and Facebook didn't exist, and neither did the smartphone. And who would have predicted that Amazon would have the leading cloud computing platform on the planet when they were just selling books? So I'm a little bit intimidated, and you should not trust what I say, but everybody else, of course, in terms of what might happen in the future. But I wanted to talk about a few trends. First trend is scale, and we've seen massive, unbelievable scaling with Moore's Law every 2 years, and it may be ending. But we're going to see progress in other areas in terms of networking and parallel computing, which I'm going to talk about in just a second, and maybe quantum computing will come about. But progress is not going to end if we're not going to see a doubling of processing speed every year. But when you get into parallel computing, okay, there's Amdahl's law, which limits the theoretical computation power of parallel computing. But we've just scratched the surface, and it requires new sets of skills and expertise to actually write parallel code effectively and well. We have some wonderful new tools like Apache Spark, which allows you to parallelize things pretty easily. But then to really work with parallel computing, I'm learning functional programming, and it's very strange in functional programming. If you do it purely, you can't write x equals x plus 1. So then how do you actually do computing? But to be able to distribute things well, functional programming really, really helps. But you have this constraint, which is a bit interesting. But with parallel computing, one of the things that I'm starting to see a lot, is a lot of the work I've done previously is very deterministic. But now, because you can run your models n times, maybe not 2 to the 32 times, you can do a lot of robustness modeling. And one of the places where I first saw this was I was working for Amazon, and my little area was when you order something, my software had to pick a warehouse for each item in your order. And we had less than a minute of processing time in order to do that because the order had to get to the factory within 15 minutes. And this was 10 years ago when we were running on 65 servers in order to make that work. And I don't know how many hundreds of servers would be required for the same problem today. But they had a real problem. Their systems were so complicated that when they wanted to open a new warehouse, or when they wanted to open up a new product line, they didn't know how their system was going to respond. And they had good modelers, good OR modelers. I know them, they're really good. But what they frequently do now is, again using Amazon Web Services, is they have an armada, is the only way to describe it, of servers on which they run their existing software under a variety of scenarios to see what will happen when they open up a new warehouse or make another fundamental systemic change. Because the computing is so cheap now, they can do crazy things like that, which is in some ways the most cost-effective way for them to get to an answer. The next thing I wanted to talk about in terms of the theme, and I've got one more after that, is that, and Brent mentioned this, the Internet of Things and connectivity. And so I'm going to talk a little bit about one of my current companies, Marchex. Internet of Things, we do call analytics. We're not the NSA. Frequently when you call up a company and it says, this call may be recorded for quality assurance, that can be us. But what we also do is we can do real-time call transcription. Before the phone rings, we can detect that the phone call was spam. And we also can detect and figure out, in many cases, for a customer calling an insurance company, what internet search did they do that led them to call that particular insurance company? Or what display ad did they see? Or they could walk into Macy's not even making a telephone call, and we can link back to some of the things that have happened. It's a bit creepy, I will admit, but we want, absolutely it is, okay? And one of the things that we do is we process over 1 million telephone calls a day. And we get about 1 billion click records a day. And we join them together using Amazon Web Services relatively easily in order to link all the different events that we can find among different potential customers. In order to trace the customer journey, as we call it, that a customer took leading up to a particular sale. So we have all this wonderful stuff going on in terms of computing on demand, parallel computing, maybe quantum computing. The tools are a whole lot better. There's one thing, though, that is still really, really hard. One is to build the actual model that is correct, current, and complete, as I think we mentioned, is still really hard. And that should give us good reassurance that we have some job security, which is wonderful. But we had Moore's Law in hardware. Can we ever get to a Moore's Law in terms of modeling, efficiency, and productivity? That's a question I'd like to leave you with, because I certainly don't have an answer. And maybe we have a self-interest and a moral hazard not to want an answer. But I think that to really see what we do more widely understood and accepted, we need to make things easier to actually build good models and do good analysis. That's my 2 cents.
Jeff.
Thank you very much. And as has been said several times already, it's a true honor to be here back at Cornell. And as I've said many times, I truly believe that my Cornell OR economics education was the catalyst for my career at P&G. And it was about 2 years ago, my dad asked me, we were having dinner, and he said, were you lucky or did you know analytics was going to become the next big thing? And I said both. And when I left Cornell, I left here with a strong belief that better business decision making was at the core of what OR was. And that companies would either make business decisions based on the science, or they'd make statistically incorrect too often, business decisions leading to bad results. Leaving P&G, I got my opportunity to start. Leaving Cornell, I got my opportunity to start doing exactly what I'd studied, which was optimization and simulation. I spent 6 years building supply chain models all over the world for P&G, saving us hundreds of millions of dollars. Now, what I want to reflect on though here is a little different than some of the comments on the evolution of technology, because I think I couldn't agree with them more, especially as I think of my data science role today. Whether it's P&G sells products to around 5 billion consumers around the world every day, and trying to understand we're the world's largest marketer, certainly one of the world's largest promoters, and trying to optimize every one of those consumer interactions is a data and analytics problem that's, I think, second to none. But when I look at where I've spent most of my intervening career between the data science position and my time in OR, it was really being an analytic advisor to our executives. It started when I built up our analytics organization in China, did the same for our president of P&G in Europe, and more recently for our CEO and for our vice chairman. And when I look at the ability to analyze business data, make unbiased recommendations on the state of the business, what likely competitive activity would be, how best to respond to different competitive environments. While those aren't directly operations research in of themselves, what I've observed over my time leading these organizations around the world is the people who do best in those roles almost invariably come from an operations research background. And so when I look, and a disproportionate number of them are from Cornell, but that is beside the point, and partially due to my continued recruiting efforts here. But I think what you see is that the fundamental focus on how can I optimize my business, how can I understand at a depth necessary to build a model and give a business decision maker insight onto the strategic decisions they need to make, is something that depth of analytic understanding is essential for. And so I think probably everyone here has seen the movie Moneyball. And there's a great scene in that, obviously a great scene in that movie where the first time the analyst is at the table and Billy Bean points at him and is like, "You want me to speak?" And shortly after that movie, there was a New York Times article that came out and said the biggest challenge is having a seat at the decision table. And what I think we've done very well in the analytic journey at P&G, and what I see as absolutely essential to both the progress of our field and the progress of business decision making, is more and more companies making that journey to have the analytic advisor at the decision table with the senior executives, helping advise them on the challenges of their business. So now, as I go into my current role leading data science, that gives me a second advantage. It also gives me an opportunity to not just discuss the challenges on our business, but also then to come back with how the solutions we're bringing together in data science can help drive that better future for the company. So what I want to leave with is effectively that I think analytics is very much the future of industry. It's very much the future of our own field. And I think the more we can focus the people coming out on understanding the business aspects and how those business aspects are, how the combination of analytic mastery, analytic depth, and business understanding provide a unique combination that will truly enable our field and our profession to be differentiated on the world stage.
So I found myself, as I've listened to everyone speak, just wanting to say, yeah, but I think the same thing, or ditto, or something. So I'll just take it on a slightly different path. As I've been at Delta Airlines or its predecessors now for 25 years, and there has been tremendous change from an OR perspective and from a business perspective through those years. Yet at the same time, the types of things that we look at, even some of the types of underlying approaches that we've used to look at them, are in some ways very persistent and very much the same. And so airlines, I think we all fly in airlines, we know, I mean, they are massive logistic and customer service puzzles. And that's what is so fun from an OR perspective. When I first went to the airline, 25 years ago. I really planned, initially I was just going to go for an internship, and then I was just going to stay for a year or two. But I think it's that puzzle that draws us in, and OR is absolutely at the heart of every single piece of it, and that has been true historically, it's true currently, and I can only imagine that that's true in the future as well. So somewhat, you saying you were the first member of the OR team. I was the first member of OR, official member of OR at then Northwest. And my own experience was that, starting as an intern, there wasn't a formal OR group, but wow, there were OR problems to be solved, and there was OR that could be applied, and there was, as Dave and I were talking about, there was data that could be taken and used in dissertations. There were all kinds of incredible things that were there. And by the time I had finished here at Cornell, there was actually a small but mighty OR team in place that I joined and then ultimately led a couple of years later. So what were the types of things that we were working on then? I was kind of thinking about that. I thought, well, the same things we're working on now. There's, crew scheduling, right? And really all of those scheduling and optimization problems that are out there. There's revenue management, that's a big one. There's network planning, there's maintenance, there's aircraft reliability forecasting, there's simulation. There was actually a quote that I had put at the beginning of it was kind of the lead in to my dissertation. I thought it was so cool because this was in the, mid-90s, and this quote was from 1969. Wow, way before the 90s. And it was saying, and what struck me about it then was, it was from transportation science, and I think the first words of my dissertation was, this was true over 20 years ago and still true today. And it was talking about the airline crew scheduling problem. And it was saying that it had been solved many times using many and varied techniques, but never to the degree of rigor that, of solution that would mean solution to a mathematician, and never to a degree of completeness that was truly valuable to the airlines. And what's fascinating to me is I could almost say the same thing today, maybe with the exception of, with all of the work that we all have put into it, it definitely is something that is of value, right, to the airlines today. Not so true in the late 80s, early 90s. But yet there's still more to be done on that, and there's more to be done really on any of these problems or in any of these areas. When Lee was talking, you made lots of comments, but one of them was that comment about messy, it's the real world and there's messy data. And that's another thing that I would point to, and I talked to some of the students yesterday, and we talked about, that in the real world is a really big deal. And so prior to coming here, I was sort of trying to touch base or get a pulse check from folks who I know who are still deeply working in some of these areas. And I said, so how much of your time do you spend on actual, kind of modeling and OR stuff versus data mining, data cleanup? And it's something like 10% math, 90%. Does that sound right to you? 20-80, depending on who you are and how mature what it is that you're working on. And so for me, so I had been leading the OR group for a while, but by the mid-90s, it became pretty clear that OR, even with the very best models and the very best people and good understanding of the business, it wasn't going to be able to be fully leveraged by the industry unless you were bringing the whole technology, IT, and data people along with it. And so at that point, I made sort of a flip over. That was when revenue management was hot, and I thought, the airline needs a revenue management model, and there are plenty of OR people who can help it. We need IT people who understand that. And so I kind of flipped over at that point to help run that effort. And then by about 2001, I actually had OR and IE back. At that point, I had become the CIO, and we had blended the IT and OR and IE together really as one. And so, how do you look at it as we answer the question of today and into the future? It's a lot of the same of what you've already heard. A lot of continued incremental improvement to a number of those initial models that are out there. But again, each of those increments is so amazing and so valuable that it's still really worth doing. As almost everyone said, a big push around predictive analytics, and that comes in a lot of ways and places for airlines. It's airplanes, it's parts, it's delays, it's cancellations, it's pre-planning weather events, it's customer service analytics, predicting attrition. Some of us yesterday were talking about, so I flew on this airline, I'm a frequent flyer someplace else, and don't you want to know that that's me? Yep. And in addition to that, I want to be able to predict what your lifetime value is so I can treat you accordingly through as much of your cycle as I possibly can. Another big area as we go forward, and it's actually one of my favorite things, well, it's not my favorite thing when it happens, but it's sort of one of my favorite airline problems, is this idea around what we call irregular operations, which unfortunately are fairly regular operations. We say IROPS, and someone said, it really should be regular ops. Okay, so, but that would be, you have this beautifully constructed plan of crews and airplanes and people and 15,000 of them going 18 million directions. And so what happens when reality intervenes? And that reality could be weather, reality could be maintenance. What happens to your crews, your planes, your customers? And it's kind of interesting, as I was talking about it yesterday, I would say from the airline's perspective, we've made a lot of investment over the past several years on the customer side of that. And actually you do kind of see Delta touted, people will talk about, oh my gosh, there was this issue that happened and they came and got me in a bus and they took me here and then I flew there. And we have put a lot of effort into how to re-optimize the customers at that point. Interestingly, the crews and planes is much harder because you have to break things that are working to put it back together, and there are questions and ethical questions about how much gets broken. But on the customer side, I was kind of feeling good and thinking that we had made quite a bit of progress. And then I was talking to Ava last night, and there is a piece, and this again points to this idea of this continued incremental improvement. We were talking about how there isn't enough customer feedback into that irregular operation point, and how do I, on a real-time basis, understand what it is that you want to do quickly enough that I can optimize and hold space for you. How much of that can I predict? How much of that do I need with an input channel for you? What do I do in the intervening time? All of those types of things. And so again, just very similar to what all of us are saying, OR, data analytics, predictive analytics, all of those things continue to be so important to the work that we do, our industries, and just what it takes to make companies run today.
It's a great honor and pleasure to be here, a part of this panel. When I stepped on Wall Street about 11 years ago, I joined the class of sort of OR practitioners that fall into this sort of quant label on Wall Street. And I wasn't the first OR practitioner, to get there. The quant revolution, if you want to call it that, had happened already, in the 80s and 90s. A lot of people with physics, engineering, computer science backgrounds had already started using their skills for either managing money or building financial models. And they were mainly seen as problem solvers, people with sort of knowledge of specific methods and techniques, people who know software and who can write software, and sort of the somewhat vague definition of people with quantitative and analytical skills. And we provided this sort of the service to the industry, but within that sort of quant class, OR was not necessarily recognized for what it was, at least early on. I felt that there was a little bit of a limited appreciation of the unique skills and talents that the OR people brought to the job, and I remember early on running into people who also had quantitative backgrounds, and perhaps they had taken an OR class when they were in graduate school, and then they thought that that qualified them to be OR practitioners as well. And if you have taken a class that showed you how to do simulated annealing or neural networks, then you didn't need to know anything more about optimization. So that was sufficient. I ran into people who would let's say build an optimization model, and they didn't want to use, or they did not know how to use a package that supports constraints. So instead of using, let's say, a non-negativity constraint, they would model the non-negative variables as the square of an unconstrained variable, and then would put that into the software and wouldn't get a solution, and would say that the software is crappy. So this kind of I think misinterpretation or underappreciation of OR came from not recognizing the depth of analytics that come with the OR training, and I think that was something that I was recognizing as a common theme as people before me were talking. I think we teach people how to do modeling. We give them sort of flexible skills that teach them how to approach a new problem that they have never seen before. And then we teach them also the limitations of both the models and the tools that they are using, so that they know when to use the right tool, and when the hammer is the right thing, and when you need maybe a finer tool to address the problem. In terms of the roles, in the quant space for our practitioners, there were several types. I myself was in the sort of the portfolio management space, so there some of the revolutionary ideas that date back to Markowitz had been recognized for a long time in the industry, and people were using these diversification-based approaches for building portfolios, optimal portfolio selection, asset liability management. These are still fairly widely used. But people also were, in many instances, very skeptical of some of these methodologies. If you put in badly estimated inputs to your formulation, then you got sort of strange-looking portfolios, and they associated this with the failure of the optimization methodology, instead of putting the blame on forecasting. And because of that, I spent a lot of my time sort of both trying to understand, fix, and also explain the portfolio construction process that's used, for managing portfolios. So I think one of the things that I found myself adding the most value in was talking to, let's say, the portfolio manager and explaining them, like when they ran their optimization process and got a particular portfolio, why it looked the way it looked. So they thought that there is this black box that generates portfolios that they don't understand, and we're we're looking for a translator. How did it get here? So that was one side. Then there were other people who were on the sort of the more pricing and valuation side of the financial industry, and I think this is also a little bit related to the development of financial engineering programs in a lot of different schools. I think the Cornell ORIE department was one of the pioneers in that area. I remember just before I left, I think in '95, we had instituted as part of the MEng program a financial engineering leader concentration. And a few years later, the Princeton OR group from civil engineering, separated into a department, became the ORIE department, and then a lot of the financial engineering programs that came up at Columbia, at Berkeley, Carnegie Mellon, they all had a lot of input from the OR departments, and part of that input was related to the stochastic calculus basis of a lot of the pricing methodologies, and with that there was a sort of a proliferation of OR background, people with OR backgrounds in the industry. One of the maybe more controversial aspects of the use of analytics came in the sort of the more securitization space, so building new financial products. And a lot of you probably remember from the big financial crisis in 2008, all those three-letter acronyms. So those were the products of these financial engineering efforts, in many cases sort of misinterpreted or badly modeled, and then as a result, led to a lot of bad decisions, and that that gave the whole sort of quant culture a bad name for a period. A lot of us, within our culture, tried to address it, both in terms of building better models, but also trying to educate people, why these happened and what were some of the things that were wrong in generating those products. Along that dimension, I remember some of the efforts, for example, understanding risk and risk measurement, and some of this predates the financial crisis. At Cornell, Dave Heath, while I was here, was working on, for example, the definition of coherent risk measures. So this really was a sort of a revolutionary idea, trying to replace the poor risk measures that a lot of financial institutions were using. After him, Terry Rockefeller also picked up that idea. He built some of these risk measures like the conditional value at rest. So these were very influential and still continue to be used fairly widely and pervasively. In terms of thinking about the future of the OR practice in finance, I think like the previous speakers, I see a lot of the potential in terms of the advanced analytics space. So we continue to see a focus on data that's both larger in quantity, perhaps also more unusual in quality. We look at data that is sometimes non-numeric, unstructured. That there's an effort to try to capture some of this data and turn them into good models. And in some instances, machine learning type approaches come to the forefront of analyzing this data, and in some other cases, it's just applying the traditional OR techniques, but just being more efficient and more complete in terms of their application. I continue to think, as I sort of think about the future of the OR practice in finance. One of the fresh PhDs that I'm going to hire from an OR program is going to come and sort of start demonstrating some new methods and techniques that I have not been sort of exposed to and familiar with, and that really hasn't happened, at least not yet. And you can sort of do a charitable reading of it, and you can say that the techniques that we teach and learn are timeless, and they will continue to be effective looking into the future. Or you can say that you can look at it a little more critically and say that perhaps in terms of developing new methods and new techniques, our field has been a little slower over the last decade or so. I think we have improved in terms of the speed of the methods, the delivery of the methods, and the kinds of things that we apply the methods to. But in terms of innovation, coming up with new methods, I'm starting to wonder, if we are leaving some of the leadership to some of our sort of sister fields, and maybe I want to finish with that thought.
Great. So let me push back on sort of more forecasting, and maybe by putting it in the context of forecasting, the natural tendency is to be cautious because it's what you really expect. So let me play modeler and frame the question in terms of a gambling question. So think about some problems, something that you'd say, oh, I would love if I had a tool to do fill in the blank. But of course that's too hard. Now of course you probably all have your favorite what that would be, but to sort of be a little bit more positive, say, and it's the one that I put $100 down today at 10,000 to 1 odds. So as you sort of think about what big problems are there that you'd see that our tools, you'd love them to grapple with, but seem too hard, where do you see the opportunities? Anyone want to take a stab?
Sure. I mean, I would say for the airline, I probably talked around this a little bit. It is in both, not just creating schedules and plans that are really efficient, but creating them that are sufficiently robust to what's going to happen. I think that's easier, and that'll happen in the relatively short term. But then secondarily, the real-time reoptimization, not just today we're working on pieces of it, right? We work on crew recovery, we work on passenger recovery, we work on operations recovery. But the holistic solving of that is going to drive a fundamentally different solution. And that will happen. I don't know over what period of time, but it will take time to.
I think one of the ones that was touched on, that you touched on earlier in terms of the consumer visibility and path to purchase. When you think of the world we're entering today, with virtually all mediums of advertising becoming addressable, whether online, TV, other traditional forms, the ubiquity of technology in your smartphone and other things to know place and time and activity, the ability to truly optimize end-to-end interaction with consumers. And it's a problem that a lot of people are touching on different pieces of. When you start thinking about the probabilistic aspects of that, the optimization aspects of what you spend where across all the different mediums available to you, it becomes an enormous combination of propensity and optimization that I think will become of absolutely enormous scale and importance.
Yeah, what we're seeing is some of the big challenging problems are in the area of real-time modeling, because all the Internet of Things, the events data, the sensors, all the feedback that we get, all the data feeds that we get, we know reasonably well how to take a model that has been built offline, the training, and then apply scoring. But as data come in, to be able to, in real time, see if our models need to be retrained, and because you have a moving window of data as it comes along, which parts of the data do you keep, what parts do you throw away? And so the stability, even things like in predictive asset maintenance, stability monitoring with a multitude of sensors giving data every microseconds, that becomes very, very difficult. I think those are some of the places where we have lots of challenges, and we are creating new algorithms, trying to modify what we have and see how it can be adjusted.
I'll try to be provocative, which isn't that hard for me sometimes. I agree with everything that everybody said in terms of robust optimization. Streaming calculations is something that I've worked with at Amazon a lot, and it's a different way of actually doing your particular processing. And I'm currently involved certainly in the advertising optimization space. I guess my problem is sometimes I'm lazy. And so, like the problem that I'm working on right now, which is the customer journey modeling, okay, I'm reading lots of academic papers. And I'm reading some of them that are really good 5 times to understand them in terms of how they might be applicable. And then I still have questions, so now I'm interacting with the authors of those papers. But then taking that and understanding how it applies to this particular situation and actually building it is far too hard. Okay? It's just really hard. And I'm not too uneducated, certainly thanks to Cornell, but it's still really hard. So as a lazy person, I'd like to have it be much easier to be able to analyze problems in a constructive, useful way. Don't have a simple answer for that question, but that's maybe it's not 1 out of 10,000, but 1 out of 1,000,000.
So maybe at this point it would be nice just to open up to all of you, both to comment and to ask questions of the panel, given the wealth of experience and smarts in the room.
I'd like to ask Teresa, and I met each other a few weeks ago. And I mentioned the greater upper bounding algorithm. And I said, with all this data or computing power available, do we really have to worry about the simplification algorithms? Her answer was yes. Can you talk a little more about that? Because those were pretty fundamental in 1977 and 76 when I was.
Yeah, and I think that, and the reason I answered yes wasn't so much about just the pure availability of computing power. I think there's a piece of that is the discipline of really driving to understand what it is that you're trying to solve and the pieces of that are important to solve, which sort of directs the analytics, directs the modeling, and directs those pieces. Now, yesterday when I was talking, I was actually, there are some aspects of simplification that are horrible, and that was one of the things that really plagued, I think, the OR and the airline industry for a number of years, that a lot of the research that was being done was making these simplifying assumptions that simplified the reality right out of the problems, and therefore, until you could really get in and unsimplify pieces of it, then not only could you get these generalized problems that were really, really, really interesting to work on and solve, but you could actually get things that were useful. And so to me, there's a balance in there. I don't think that just throwing things into the magic cauldron and waiting for the magical solution to bubble out is the answer. Some degree of simplification is a discipline that drives the analysis. That's my opinion on it.
First of all, I want to thank all the panelists. That's a very thought-provoking. I have a rather rhetorical question, not aimed at anyone in particular. We've heard a lot today, and we do a lot of work collectively in predictive modeling and modeling for uncertainty. Do you think as a field we are doing enough to understand and address the underlying causes of uncertainty so we can reduce it before then applying our exciting models?
It is a provocative question.
I'll begin with just coming back to the example that I given, where people who are responsible for quality are moving away from just reporting on it and having static views of the past, and trying to take these new data sets, these new stacks of information, and be able to anticipate, if they change nothing, what should they expect in terms of performance out of their operations for the next 2 or 3 reporting periods, if you like. But then after that, to say, well, now let's drill into certain things and understand what are those causes? Because oftentimes, and this is what we're learning, the things that people think are driving failures are oftentimes not exactly the real root cause. And so that's just starting to scratch the surface, I think. And so it's maybe a rhetorical question on your part, but I do think that the short answer would be we should be doing more. And I think that's where the action is to be able to understand really what are the true root causes and to zoom in on those and make adjustments there, as opposed to turning dials and knobs after the fact, hoping that you're going to get it right.
The sense that I have is if you're trying to reduce uncertainty, that can be a synergistic process, where if you build a probabilistic model or some kind of model, you can, if it's done well, you can understand some of the root causes of that uncertainty and then introduce changes in order to change them. But then there are other situations. I can't control the weather, and the airlines can't either, though I wish they could actually 2 days ago. And in some of the work that I've been doing recently, it's what customers choose to do. And I can't control that very much, at least not initially. And yet, the best type of model is a probabilistic model, so we get to do that in that context. But if you're running a factory, reducing your uncertainty should help a whole lot.
So, in addition to, I think, trying to reduce the sources of uncertainty, in some cases we accept that, uncertainty is there, and we try to reduce the consequences of uncertainty. So this is especially sort of in the financial setting, that's possible through these instruments that people create, hedging instruments or insurance type of products, and we cannot control the uncertainty about the weather, but farmers or people whose productivity depends on the weather patterns can actually use these products, these financial products, to limit their exposure, so that if the weather is bad this winter, you're not wiped out completely. So some of that is possible, and the OR practitioners are helping build those instruments. And so when you cannot eliminate uncertainty, at least you can try to eliminate its consequence.
Sam.
As I go back to my experience and also listen today, there seems to me the three key elements of the practice of operations. One is the ability to develop the optimization and the analytical tools. Another one is the skill to be able to model reality and understand what are the important parts of reality that we need to model and work with in doing that analysis. And then the third one is the ability of the practitioners to communicate with the decision makers, with the people that are on the factory floor, if you will, that have to implement this stuff to get buy-in and to move the ball forward. As you all look at the future of where Cornell ORIE is going, where would you put your emphasis on those areas?
I'll start. I'll give a smart-ass answer, which is all of the above. But the last one that you mentioned, I think, is where there's the greatest opportunity right now. The idea of creating these tools and models and so forth, and understanding them and developing them where they're credible and correct and all the rest is one thing. But then as you push those capabilities deeper into the organization, so not just communicating to factory workers or line operators, but actually empowering line operators to take that information and to act upon it in their own way. That's really, to me, one of the frontiers to take this and push it as deep into the organization as possible, whether it's in a commercial part of the organization or manufacturing or whatever it is. That has huge implications for skills, for how you train people, how you measure them, and what they're held accountable for. So to me, that's an area that probably is not getting as much attention as the first two that you mentioned.
Yeah, I would say that as a part of the curriculum, a key part would be training the students to work as a team. I think that possibly, as a practicum or something that they can work together, where you put different skill sets together, and being able to explain what each one does to the other is, I think, a very, very important aspect. And I think communication, I would say, is something that we have to.
I have a question for each of the panelists. Lee Shrewden said he's a co-op student. I was a co-op student. Chris is a co-op student. Would you be willing to take on a co-op student?
So we have a lot of internship programs at SAIS, and we do have a few folks from Cornell as well.
I'll be going back to my company and asking them, but I don't write the checks.
Good.
I was going to say, Max, one thing
It goes to the number of people in the audience.
Yeah.
As well.
It's incredibly important with respect to building the field. There's no way I would have been able to do what I did without, and again, mine was sort of non-traditional, right? But that was absolutely critical to that learning and development. And I think to that point, I would absolutely agree that number 3 is probably the area of biggest weakness of people coming in. But there's also another piece, and I don't know if it comes through that co-op experience and then coming back to an educational environment after that, but it's that confidence that the really good OR practitioners are the ones who have the confidence and the ability to go in and sort of see between the lines. I mean, again, maybe going back to Lee and his presentation of seeing, yeah, wait a second, you're solving this problem over here, but wait, there's a big OR thing in there. We can help you. We're from OR, we're here to help. And that some people are good at and some people just aren't. And so I don't know that I have a suggestion of how to build that, but maybe getting a degree of that co-op experience is what it is, that you have the co-op experience, then you come back into the educational environment to grow.
I led an effort at my firm this past year to do recruiting specifically targeted at OR PhD students, and that resulted in intern hiring, and also we looked at full-time hiring. But this was unique in the sense that we do recruiting in all fields, but this OR effort was very much targeted. We went to the informed meeting, we reached out to a lot of faculty, I reached out to David, and yeah, I'm still looking for good OR students, both to hire as interns or co-op students.
The interns and co-ops are used in the same sentence. I think it's important to understand the difference in the co-op program is this is a 3-year commitment. You start after your freshman year. I did, maybe sophomore year, but you're going to do 2 full semesters in the summer. And they know you're going to come back. It's not like an internship where you're different people. So they make that investment in you. That long-term commitment is the important part about a co-op versus an intern.
So I want to just give one round of applause for the panelists really for their